Today we're going to go over medians, altitudes, and mid segments, geometry, honors geometry, SOBA on Trooper Tide Tuesday. Use and identify medians, altitudes, and mid segments, section 6.2. Use and identify medians, altitudes, and mid segments, section 6.2. Right? Okay. So, these are other different parts or properties of a triangle, so to speak, okay? Oh, yeah, look, it's all nice and calibrated now.
You're welcome. Okay.
So, median, we first have to define what these things are because we don't know what they are. A median, okay, is a segment, it's a line segment whose endpoints are a vertex of a triangle. A vertex of the triangle is there's three vertices. A vertex of the triangle and the midpoint of the side opposite the vertex. And so its endpoints of the segments have endpoints, are one of the vertices, and it goes to the opposite side's midpoint. Okay? Why could we not go from a vertex to another side's midpoint?
Because it would not be the same. Well,
because then it'd just be part of the side of the triangle, wouldn't it? Okay? So that wouldn't work, okay? So how many medians do we think there are at any given triangle?
Well, 3.
What about from here?
Yeah,
Could that be a median?
Yeah.
Yeah, if this is the midpoint, that'd be the median. Could there be one more?
Yeah.
Yeah. Okay. There could be one more there. Okay. Dig root. Okay. Questions on that? That's just what a median is. Truthfully, we're not going to do a ton in here besides just identify the median. Okay, we're going to do a few problems of saying, like, we're not going to do them in the notes, we're going to do a few problems, like, on the homework that just say, hey, this is a median. So what are some measures? But that just means what we need to know from that is that it connects to a midpoint. So these sides would be congruent. We'll see that in the homework.
And she's back.
So, did you run that? If you want to run the halls and not get in trouble for it, you can join soccer conditioning. We were running the halls yesterday. It was a good time. Okay. So altitude, an altitude. An altitude is a segment that is from a vertex of a triangle. So once again, it's a segment that goes from a vertex of the triangle. But this time, instead of going to the midpoint necessarily, it goes to where it's perpendicular. That's our symbol for perpendicular because I'm lazy and I don't want to write it. To the opposite side, or to the new line containing the opposite side. I'll talk about what that means in a moment. So instead of a median where it goes from the vertex to the opposite midpoint, it goes from the vertex being perpendicular to the opposite side, which isn't always the same thing. Like here, it looks like this is not the midpoint as well. Okay, it looks like it, but it's going to the right angle. Now the reason it's called an altitude, guys, the reason it's called an altitude is because altitude, what do we think of when we hear that?
Height.
Height, mountain, elevation, up and down, height, something. So if we're measuring height of something, should I be like slouched all over and bent all over like this? Would this be a good place to measure my height?
Yes.
No, okay. I want to be straight up and down. I want to be perpendicular to the ground, okay? I want to be perpendicular to the ground to measure my true height, okay? So just in the same way, we want the segment to be perpendicular to the edge of the triangle, and this would be the triangle's height. This would be the triangle's height. Maybe that's something you want to write in right above the altitude or right below the altitude, that it is the triangle's height. Okay, this is the height of the triangle. How many altitudes do we think are in a triangle?
31.
Oh, well, I'm going to go with 3 because does that also go from a vertex to being perpendicular to the opposite side? Yeah, and I think we'll have one more here. Same thing. Okay, so it is having 3 altitudes as well. So depending on how we spin the triangle and how we look at the triangle, we have 3 different altitudes. Okay, And yes, that means the height can be different depending on which way you're looking at the triangle. Height can be different, okay? But we'll talk about that more actually like way later in the year. Okay? We'll talk about area of a triangle, of what we need to consider the height. But the height can actually be any of those three altitudes, and yes, they can be different. Kind of neat.
Pretty neat.
Yeah, it's pretty neat. Yes, you can tell because of the way it is. Remember that neat walk video earlier in the year? That's a great one. I love it. Okay. Any questions on this, guys? Alright. Now I said a moment ago that the altitude goes to the opposite side or the new line containing the outside. We'll see that here. Because an altitude can either lie the altitude can either lie inside the triangle, like in this first example, we see the altitudes entirely inside the triangle. Here, or excuse me, on this last one, I really need to rearrange this order. On this last one, the altitude's actually on this triangle, because this could be out the altitude, or this could be the altitude here. So either of those could actually be the altitude there. Because this goes from a vertex to being perpendicular to the opposite side. And this goes from the vertex to being perpendicular to this opposite side. So it can be inside, it can be on, or what do we see here? Where's the altitude? It's outside the triangle. Okay? It's outside the triangle here. Because in this middle example, this middle picture here, there's no way we could have drawn from vertex A anywhere inside or on the triangle and made a right angle. The only way we can make a right angle and make it perpendicular, okay, is to go straight down here, and then we have to make this new line containing it. And that would still be considered the height of the triangle. What we did was we just took a straight edge and you just continued this along. Does that make sense? Okay. So blank is the altitude in each triangle. What do we think is the altitude in each triangle here? Like what part? Segment
Baby.
AB. Segment AB is acting as the altitude in each of these. Okay. Question on that? Okay, so sometimes I try and like scratch like my eye because it itches. Okay, and it gets really mad at me. It doesn't even scratch my eye.
Okay, but the bad thing is, I've actually done that when I started bleeding.
That sucks.
Like I scratched my eyeball, and then there was like that blood patch that you get.
Riley, nobody understands
The
you.
broken blood vessel. Yeah, I don't know. Shut up, Peyton.
And you're crusty.
Be careful. I don't know what carrot.
Okay.
Boom, sucker.
You're so funny.
Tell me something I don't.
Mid segment. Last part we're going to learn about today. This is one we're actually going to use quite a bit. We're actually using mid segments quite a bit here.
So we're just doing this.
Okay. Mid segment is a segment that connects the midpoints. Hence mid segment. It's a segment that connects midpoints. We're really clever with names in here, guys. Okay. Mid segment that connects midpoints of two sides of a triangle. Okay? So it connects to the midpoints of two sides of the triangle. So here we can see in this picture, we have the big triangle ABC, the big triangle ABC here. And we see on side AC, what's the midpoint? D, because we're told A to D and D to C are congruent by the tick mark. On the side BC, what's the midpoint? E, very good. Because we can see B and E and C and E are congruent. So, DE, segment DE connects those two midpoints. Segment DE connects those two midpoints. So, we would say segment DE is our mid-segment here. Segment DE is our mid-segment here. It'd probably be a good idea to write that in there so that way we know what the mid-segment is. Segment DE or ED would be the mid-segment. It's a segment connecting midpoints. Okay? And once again, there are going to be multiple mid-segments in a triangle. There are going to be multiple mid-segments in a triangle. I don't want you guys to draw this part in. But if I were to have a midpoint down here, let's call it F, I could also connect D and F, or F and E, okay? And then have another mid-segment here. Any nerds out there, this is the Triforce right now. Okay, just a little stretched out from Legend of Zelda, but I'm there myself. I do love Legend of Zelda games. They're like one of my favorite series ever. Anyway, played a lot of them. We have this triangle mid-segment theorem. Triangle mid-segment theorem. Okay, we love theorems in geometry. They're so much fun. Okay. I can tell you guys' excitement when I said the word theorem. You guys were just like, whoa, okay. I don't know if anybody heard you guys besides me, but I heard it. I know it's true.
Are we adding that to like
Oh god,
Like the
it's gonna
proofs?
be even more for
It could be improved.
It could be, so it's improved. I forgot.
we're still wait, are we
Oh no.
Proofs never go away.
No.
That's what gets me though.
Oh.
That's why I failed this last test.
Oh.
Oh,
What do you
wait.
mean gets me as in trips you up, or like
No.
gets me as in like they understand?
You failed because of
Proofs
proofs.
go in algebra
There was 2 proofs.
You don't have proofs in algebra right now? Oh, nice.
We didn't have it last time.
Wait, are we going
Yeah, you don't usually
You're
have.
looking at me, Kevin.
It's usually like geometry concepts.
Yeah, don't want to take that.
Just
That's
your
fine.
proofs and you failed.
Hey, thanks,
What's he do?
Justin.
Triangle mid-segment theorem. The segment joining the midpoints of two sides of a triangle, aka the mid-segment. Let's read this first part again, guys. Kevin?
Yeah.
Let's read this first part again. I'll have you read this first part. Go ahead, keep reading until I say stop.
The segment joining the midpoints of two sides of a triangle.
Stop. The segment joining the midpoints of two sides of a triangle. That's just saying the mid-segment. That's just saying mid-segment. That's the long, wordy way of saying the mid-segment. Okay? The mid-segment. Now if we continue, the mid-segment is parallel to the third side, and its length is half of that side. So in this triangle, mid-segment DE, what do we know about mid-segment DE then? It's parallel to AB. We draw that with arrows. And what else do we know about it? It's half of the length. So we know that the measure of segment DE would be half of the measure of segment AB. You know the measure of segment DE would be half the measure of segment AB. So let's say, for example, if measure of segment AB was 10, what would the measure of segment DE be? 5. Boom, half, okay? What about if I said that the measure of, what if I said the measure of segment DE was, 7?
14.
AB would be 14. Okay, we double it. Okay, make sense? Okay, cool beans, cool beans. Okay, yeah, beans are cool. Frijoles Cheetos, frijoles Cheetos.
No.
Okay, means cool beans in Espanol. Okay, frijoles Cheetos, cool beans.
That's pretty deep.
It does.
I don't think it does.
Okay, you're wrong.
Yes,
Let's
it
bring someone
literally
else.
does.
Forget. Yeah.
Oh.
Frijoles Cheetos, cool beans.
No, wait, Cheetos, like no.
Frijoles Cheetos.
Cheetos is like.
Cheetos means cool?
Cheetos. Okay, you were saying Cheetos.
Frijoles Cheetos.
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 Frijoles Cheetos.
No. Frijoles. Sorry, you gotta put some put some phlegm on that J. Frijoles.
Yeah, frijoles Cheetos.
Frijoles.
Okay,
Literally, no,
example
it doesn't.
7.
Cool Beans literally is not that.
Okay.
It's frijoles Frios.
Oh, you want to say
That's not what my students at Omaha South told me when I cussed them.
Okay, well.
I wouldn't trust
Cool, like
I do.
cold is Frios.
Especially considering a lot of them grew up speaking Spanish.
It's so hard.
Given triangle ABC, we have this triangle ABC. And what are we told about this triangle? Midpoints.
X, Y, and Z?
We're told X, Y, and Z are midpoints. Okay, so if X is the midpoint, what do we know about AX and BX?
They can do it for each other.
They're congruent to each other. One tick mark. What else can I mark on here right now? AY and CY. I can put 2 tick marks there. Okay. What else can I mark?
Z, Z, and ZC.
Is this purple hard to see?
No, I'm talking about my paper.
Oh, yeah, it's kind of hard to see. I feel that. Metaphorically speaking. Okay, so we can mark all that information, okay? So xy is parallel to what here?
BC.
How do we know that?
Triangle.
Because xy is a mid-segment. It connects two midpoints, x and y. So we know it's parallel to the third side, BC. Okay? If xy were happen to be 5, what would BC be? It is also half its length. Okay? Get interesting here. If AC were to be 30, what would XZ be?
15.
15. If you change it up mid-segments, but XZ is still a mid-segment, connects two midpoints. Okay? Question on that?
No.
No.
Okay? Let's look at the next example then.
Keep
on trucking along.
Hopefully it doesn't happen.
Yeah. Good luck. Yeah. I always wish for luck. Okay. Try baby blue. So once again, on the triangle on the right side, we're given the same setup. Triangle ABC with midpoints x, y, and z. So let's mark the same information. AX and BX, AY and CY, BZ and ZC.
Okay.
Now, on here, we're told if AB is 5x plus 10, AB 5x plus 10, and YZ is 3x minus 8. How could we find YZ? Well, we need to find x first, so how can we find x? Sarah.
You put 5x plus 10 is equal to 2 times 3x minus 8.
Very good. 5x plus 10 is equal to double or 2 times the quantity of 3x minus 8. We have to make sure we do 2 times the quantity, times in parentheses, the whole thing. Okay? Yeah, that'd be exactly right. Okay? Is it true that AX would be congruent to YZ, by the way, guys? Sure. Would AX be congruent to YZ here?
Yes.
Yeah, because if AX is half of AB, well, YZ is also half of AB, right? Yeah, that's another way we can think about that. So, does this equation make sense? Okay, I want you guys to go ahead and solve this equation for X and plug it into YZ. When you have it or have questions, I would love for you to raise your hand. When you have YZ or have questions, I want you to raise your hand. Carly, you don't have a check? No. Buzz, you don't have a check? No. Like, have you been like done for a while though? Oh, okay, that's what, sorry. Yes.
Riley, thanks for getting the door. You're a true blessing.
Oh, it's good.
Just kidding.
Just, it's.
Get out of here. Oh, don't even.
Rather have it on a home video test.
Hey, how tall are you?
5'4".
I'm so did you do that equal to each other?
What do you do that?
Accurate, yeah.
Then you gotta plug it back in.
Oh.
It's not negative, I for this year, yeah, so last year.
Nice.
Cause like, well, okay, so when you get to here, when it's 21x equals negative 26, when you divide by the negative 1.
Okay. Peyton, did everything go well? No bad interactions?
There was good girls in there, so I'm convinced they were.
Happy to hear that.
Unless she comes after me at the end of class.
So as we go through this, we get 5x plus 10 is equal to 6x minus 16. We get x is equal to 26. We plug it back in to 3x minus 8 to get yz. 3 times 26 minus 8. 3 times 26 is 78 minus 8. So a measure of YZ is equal to 70. Could we have also plugged it into A, B?
Yeah.
Yeah, but what would we
Then they
get?
have to have-
140, so we get 10 divided by 2, right? Does that make sense?
Yes.
Any questions?
Change.
You guys are great.
No.
That makes sense? Change.
Oh, my knuckle hurts. Here.
Yes.
When you add 10.
Maybe you add 10. Yep, you're good. You're good. Given triangle OPQ, given triangle OPQ, with the coordinates 7, 2, negative 10, 5, negative 2, negative 4, it's graphed there.
Sorry.
Okay. Find the coordinates of the endpoints of each midsegment. Find the coordinates of the endpoints of each midsegment. Okay, what kind of points are the endpoints of a midsegment? They're midpoints. They're midpoints of the sides of the triangle. So what do we actually have to find?
Find the midpoint.
Find the midpoints. That's why it says midpoint of PO, midpoint of OQ, midpoint of PQ, right? Because we find those 3 midpoints, we found the coordinates of each midsegment, right? Okay. How do we find midpoint? If we're going to find the midpoint of PO, let's think of PO.
Is it 1 times half?
Close. No, that's slope. That's slope.
Rise up
What?
1 times
That's close.
The x1, x2, and like parentheses or whatever.
Okay. Sarah?
Isn't it the square root of?
No, that's the distance formula. We'll use that one later.
Did I get the parentheses right? Is it the
There
x1?
are parentheses, but I'm not sure exactly which set. There's a couple of them where there's parentheses. So there's parentheses in this one, but there's a couple of them that have it. Yeah.
rise over 1 times half.
Nope, nope. It does have to. We kind of have. So the closest idea I've heard so far was doing was for a midpoint to be like x2 minus x1 over 2. Was the closest one I've heard so far. It's not quite right, Eva.
x2 minus x1 over 2 plus y2 minus y1 over 2.
Okay, so you're saying y2 minus y1 over 2. Okay, so I agree with the idea that we need to do an x, we need to do a y. Okay, but the part I disagree with here, or there's 2 little parts I disagree with here with what we formed, is we actually need to add x2 and x1 and add y2 and y1. And we don't need to have a plus there. We need to have a comma because this is an ordered pair. What you do is you find the average of the x's. So you add to find the average of something, you add them up and divide by the number that we added. The number of things we added. So in this case we're dividing by 2 because we're adding 2 things. So we find the average of the x's, the average of the y's. So for p comma o, you'd have negative 10 plus 7 divided by 2 for the x, and the y would be 5 plus 2 over 2. Does it really matter which x we put first and which x we put second?
No.
No, because we're adding. We don't care the order we have. So what's negative 10 plus 7? Negative 3 over 2. What's 5 plus 2? 7 over 2, okay? Now we like decimals when we graph. We typically like decimals when we graph, okay? So what's negative 3 has in decimal?
1.5,
Negative 1.5. And what 7 has in decimal?
3.5.
3.5. So negative 1.5, 3.5. So if we were to graph this, negative 1.5, 3.5. And hey, does that look like it's in the middle of PO? Yeah. Is it actually on the triangle too? That'd be a good check. What happens if you get something that's not even on the triangle? Probably made a mistake. Okay, so we probably should go back and check the rate. Okay. Does that make a little more sense? Okay, I want you guys to go and try and find the other 2 midpoints. Once you have the other 2 midpoints, I'd love for you to raise your hand. Or if you have questions, I'd love for you to raise your hand, okay?
I can't read it.
Okay, so the midpoint, midpoint is you take your x plus x divided by 2, comma, your y plus y, and divide by 2. And truthfully, we don't care about the order of the x's, we don't care about the order of the y's because we're adding.
Riley. Be quiet. I didn't ask Peyton. Oh, I'm so good.
No important.
Only in first lesson.
Sure.
Oh, do you have to do both of them?
Please and thank you. Hey guys. Yes, she's green. You guys high five, guys. I think you can high five too. That's you don't have it. Can I get a high five? See you guys. Have a great day. Why is it negative? They'll always have this. The numbers work out well.
So I'm just going -1. Oh, wait, no.
That makes more sense. I'm gonna do it.
Oh, have you read? Reply.
Oh, that's
Oh.
I did that.
Oh,
So we end up getting for OQ, the same OQ, the midpoint ends up being 2.5, comma -1. For PQ, we end up getting the midpoint to be -6, comma 0.5. Okay. And then if I went and graphed them, all the midpoints end up on the triangle, so these are my 3-minute segments, correct? Any questions on that? Is there another way we could double check that maybe this right here is actually a mid-segment? Could we check that if it's that it has to be parallel to PO? Could we check that by finding the slopes? Okay, we don't have to, but could we? Sure, we're actually gonna go through in a moment, we're gonna prove that something is a mid-segment. Okay? So any questions on this? Okay, and so the last thing we're gonna do today on our notes is actually go through and just what I talked about, is proving we have mid-segment. So, we're given triangle JKL, and we're given the coordinates. We're supposed to prove. We're doing the last one? What you said?
I'll copy it.
Okay. We're supposed to show that the midsegment MN, which isn't formed yet, is parallel to JK. So we need to show that this midsegment is parallel to JK, and that it's half its length. Our total parenthesis, M is the midpoint of JL, so we're gonna have an M that's the midpoint of JL, and an N that's the midpoint of KL over here.
So it's gonna be in the middle?
So we need to prove, so it's gonna be connecting these two sides, JL and KL, okay? We need to prove We first of all need to find out where this midpoint is, where this mid-segment is. Then we need to prove that it's half its length and that it's parallel. So the first thing we're going to do is we're going to find the two midpoints. So one, find the coordinates of the midpoints. So we need to find the midpoint of JL. Find the midpoint of JL. Okay, so we're going to do the same thing we just did 3 times where we found the midpoint. We're going to do the same thing a couple more times. Find the midpoint of JL, and find the midpoint of KL. So for JL, you take -2 plus 6 divided by 2 for the x. And for the y, you take 3 plus -1 and divide by 2 for the y. 2 plus 6, that's 4 divided by 2. 3 plus -1 is 2 divided by 2. So it's 2 comma 1. And now we were told this midpoint is to be called what? M. So we're going to go over to 2 comma 1, and we're going to plot M. We're going to do the same thing with KL. We're told to call this one N at 5 comma 2. So now we know where the mid-segment is. So now, 2, we have to show the mid-segment and side have the same slopes to prove they are parallel. Because we're asked to show the mid-segment is parallel. Well, in order to show that, we need to show it by the slopes. If we know the slopes are the what, then they're parallel. The same, the exact same. So let's first find the slope of JK. Okay, we can either do that by rise over run counting on the graph, or we can use y2 minus y1 over x2 minus x1. Okay, either way, once we have actually the graph here, I just like counting. Okay, so it rises 2, it runs 7. Is that what you said? Okay. I think it's 6, isn't it? So the slope is rise over run 2 over 6. Does that simplify? The slope of JK is 1/3. What's the slope of MN? 1 over 3, right? Because it goes up 1 over 3. So the slope is 1/3. So are the slopes the same? So are they parallel? Okay. So we know here that segment JK is parallel to segment MN. That's one of the things we're supposed to find, right? We're supposed to prove or show, which is what we show by the slopes. That's how we show it, how we prove it, that they're parallel. Now we need to prove it's half its length, so we need to find the length of both of these. So this is where we use the distance formula again to find the length. You guys love the distance formula, right? Let's write it down after let's forget. Distance formula. Does anybody remember what the distance formula is?
I have that.
Isn't it like x
Close. Squared.
minus plus?
I don't know why I put that 2 down there. I need to change that.
And then all like a square root.
Yep, and then it'll all be just under a square root. Okay, so it's the difference in the x's, square it. The difference in the y's, and square that. And you add them together, you can square the whole thing.
Who
Okay.
came up with this formula?
It's actually
Some people
derived from the
remember that.
Pythagorean theorem. We'll talk about that later. Yep, that's next chapter. So we'll go through we'll do the distance formula with these real quick. So for MN, we do the points M and N. So we have the point 2 comma 1 and 5 comma 2. So we go through the square root of 2 comma 1 and 5 comma 2. So it really doesn't matter actually the order we do on these. Yeah, actually it really doesn't matter the order we do it on these because we end up squaring them anyway. So we can do 5 minus 2 if we want. I don't know why I did that. 5 minus 2. Plus, then we can do 2 minus 1. And square that. So d is equal to 3 squared plus 1 squared. So d is equal to 9 plus 1, the square root of 9 plus 1, aka the square root of 10. Whew. Now we can figure out the approximate of that by putting it in the calculator.
There
And
is
saying
no
square root of
two
10.
positive.
What was that?
There's no two positive. Only a two negative.
What are you asking?
Like, in the thingy, J is negative two. So would that make that one negative?
The distance can't be negative. The distance has to be a positive length because it's a measurement. But we're doing between m and n. M is 2, 1, n is 5, 2, and so you x minus x, y minus y. End up having the square root of 10, which ends up being approximately,
2.15.
very good, 3.16.
What?
Yes. Then we can do the same thing with the length of JK. This time we're using the points J and K, so negative 2, 3, 4, 5. The distance is equal to the square root of the x's. I'm going to put the k's first. 4 minus negative 2 being squared plus 5 minus 3 being squared. Well, 4 minus a negative 2, that's really 6 being squared. 5 minus 3, that's 2 being squared. Distance equal to the square root of 36 plus 4. So distance is equal to the square root of 40. At first glance, we might see that and say, oh, well, that's actually square root of 10 can't be half the square root of 40. But if we find out the approximate, what do we see? What do we see the approximate to be, anybody? 6.32. So what do we actually notice? Is 3.16 half of 6.32? Yeah, and 6.32 is double it. So does this show that it's half its length? Yeah, so it does show that it's half its length, okay? So one thing I want us to write off the side, just like we wrote this off the side, is that, I'm actually going to write it over here just because I ran out of room, is that the measure of segment MN, oh, I didn't equal there. The measure of segment MN is equal to 1/2 the measure of segment JK, which is what we were asked to show. So we asked to show both that and that they're parallel. Whew. That was a lot, wasn't it? Okay. Lesson reason I have to forget. We got a little delayed because of the discussion earlier of, on kind of pathways for math classes, math courses. Yeah, math path, a math path. But it was good discussion needed to have. This is a homework, okay? It's homework. You'll see a staple on it. You'll be like, Mr. Collison, why is there a staple on it? There's only one problem on the very last page, on that third page that made it go long. So heads up on that. Yes. So for this last little bit of class, while you're working, if you have your schedule out, if you know what you want to do, okay, let's have your schedule out. I'll come around and I'll kind of sign those real quick and talk with you real quick. You need another one? I guess. I could do that.